here. So chapter 11 is all about optimization, and we're going to start with the visual of it. So what it looks like visually. So we're going to start with what's called first derivatives and their graphs. So let me share my screen. So when you take a look at all these graphs, get all this stuff out of the way. When you take a look at all these graphs, we're going to match these. So on the left, A through H is what I call test charts. Okay, these are called test charts. And the minus sign, this is all based on the derivative. So if you notice over here, it's that F prime. So what they're talking about is, what is my slope doing? Okay, so when you have a minus sign, that means your slope is going downhill. When you have a plus sign, your slope is going uphill. So what these test charts do is it allows us to see, okay, what is my graph doing? What is the slope of my graph doing? It also allows us to see, if you notice, it goes down and then it goes up again. So with these test charts, I'm going to do them with arrows, not the minuses and pluses, because it actually gives you a visual. Your mind will kind of fill it in as far as, what is my graph doing? It's going down, it's hitting 3 right here, and then it's going back up again. Then you notice above 3, and these all have a 3. Above the 3, there's either a 0 or an ND. The difference between those two is, remember, this is the slope. So when you have a 0 slope, do you remember what kind of line that you have? Anyone remember?
It's on a straight line.
Yeah, it's a straight line. It's a horizontal line, right? So we have a horizontal line like this, and our slope is 0. What if you have a vertical line like this? What's your slope?
Undefined.
It's undefined. Yeah, it's undefined. And that's what that ND represents. It's considered not defined there. Okay, so again, horizontal line, you have the slope of 0. Vertical line, you have a slope of undefined or ND. Okay, so that's the difference between these two. Now, where does it become undefined? Well, it becomes undefined when it comes to a peak like this. So if I were to bring, I'm looking for the slope anywhere on here. If I want the slope right here, my line is going to be like this. It's going to be vertical. Excuse me. Or if I want a slope right here, my line is going to be vertical. So that's where the ND comes in, okay? If it is a slope here, you can see I have a horizontal line. So that's where my 0 slope comes in. Okay, so that's what these charts are indicating. The test chart tells you what your slope is doing. The graphs are the actual graphs. So what we're going to do is we're going to match the test chart with the actual graph. So let me give you an example. So on A, I'm looking for a graph that my slope goes down, and then it flattens out, and then it goes up again. So if I look at 19, my slope right here is positive. This is a positive slope. And then it goes to 0, and then it goes to a negative slope. So 19 does not match A. All right, so now I'm going to look for something else. So I look here. If I look at 26, if I have a slope here, now it's a negative slope. It hits that 0 mark, and then I have a positive slope. So this test chart matches the graph of 26. Okay, so that's what you're looking for. Now, if you notice, all of these test charts have 3 on their test chart. These 3s are what's called a critical point. Okay, so if you look at graph number 26, This critical point right here is 3. What happens when it hits that 3? Well, this is that critical point where it changes, right? It was a negative slope. It hits the 3 and changes to a positive slope. So that's why it's called a critical point, because something happens there. It's critical. Something made it go from a negative to a positive slope. All right. So if you're looking at it in terms of business, if this was my profit function, here my profit is decreasing on this side. Something happened right in here, and now my profit is increasing. So as a business owner, I want to know what happened. What happened in the economy? What happened to inflation? What happened, was there a run on, toilet paper, right? So something happened right at this critical point that made my profit go from decreasing to increasing. So critical points are going to be critical. They're going to be very, very important, because that's where things happen. Also, because it went down, right? It goes down and then it changes and goes up. This critical point is called a minimum. All right. That's the only time you can have a minimum, is when it goes down and then it goes up again. All right. So critical points are important, because that's when you can find minimums. All right. It's also, if we look at number 19, it's also something was increasing, it hit this critical point, and then it decreased. So again, if this was, say, my revenue was increasing, something happened right here, maybe the 3rd year, 3rd month, 3rd whatever, 3rd decade of my business, something happened to my revenue and everything tanked, right? So again, that's the idea of, you can find out something very specific at a very specific point and find out, all right, what happened right there at that point? Well, on this one, you can see I go up and then I go down, up and then down. So this critical point right here is called my maximum. Okay, so when it goes up and then my slope goes down, this is called a maximum. And your minimum and your maximum only happens at the critical points. So this is the only place where max and min happens. Okay, so that's what you're looking for. That's what we're working towards, is we're looking for optimization values. So optimization means maximum. Optimization also means minimum. So optimization is just the two extremes, the high and the low. Okay, so when we look at these test charts, that's what we're looking for. So if I go back to the test chart for B, it's my slope is decreasing, then something happens, and then it increases. Okay, now the difference is, now I have an undefined value. So who wants to try this out? Which graph do you think goes with B? It decreases and then it increases, and at that critical point, it goes to a vertical. Anyone have a guess?
40.
Okay, number 20. All right, so let's try it. We had a decreasing, so we're good there. Then it went to vertical, so we're good there. And then it went to increase. Good, so this is number 20. Okay, so any questions on what we're looking for?
This is optimization, right?
Yes. So what we're doing is we're looking to see if there is a point where it's a maximum or a minimum. And you'll see on some of these that it doesn't. So, and it has to happen where it's going to go down and up, or up and then down. Okay, so like on C, we go up, we hit a horizontal, and then we go up again. So you can see there's no change in direction with our slope. It just is a continuous going up. So when I look over here, okay, this one, it goes down and then it goes to vertical, so that's not going to work. This one, it goes up and then up. So I'm good there, but here it goes to vertical. So it has to be right here. It goes up, then it goes to horizontal, and then it goes up again. Okay, so you can see there's no maximum or minimum. It's just a continuous positive increase, which if you were a business owner, you'd be thrilled, right? It would be a really good thing to have a continuous increase. Now, if this was, and again, this is my critical point at 3, if this was my, say, my profit, I could look at this and go, okay, I was increasing, doing great. Something happened right here at 3 years, 3 months, 3 decades, whatever the 3 represents. Something happened where it flattened out. I wasn't losing money, but I wasn't increasing anymore. And then it continued back up to increase. So you can go back through, you know, different scenarios in your life and go, okay, where did something increase, flatten out, and then increase again? And there's lots of different scenarios where that could happen. So C is going to be 25. Okay. One example that I can give of this is like weightlifting, right? Or even if we were going in the negative direction, like on this one, we're going down and then down. If you're doing a weight loss program, right? You're always going to plateau. Whether you're increasing in strength, you're going to do really, really good. You're going to feel great. And then all of a sudden you cannot get past pressing, you know, whatever, 150 pounds. And then all of a sudden something kicks in, and hopefully it's not steroids, something kicks in and you are able to increase again. Okay. All right. So D, same thing. We're increasing our slope, but in the middle, at that critical point, we have a vertical line. So which one of these do you think is going to be that? So let's see, we have this one is gone, this one is gone, and this one is gone. Okay, Nathaniel says 21. Does everyone agree? Increasing, vertical,
Yeah.
increasing. Good. There it is. Okay, so this is the visual that we are looking for. We're looking for where do things change. So on this one, on E, we're increasing first. We hit a horizontal line and then it decreases. So do you see, hopefully in your mind's eye, you can see it goes up and then it goes down. It goes up and then it goes down. So this one is right here. We go up, we hit that horizontal, and then we go down again. So this is number 19. And this, because it goes up and then down, this is what we call our maximum. Here, we went on A, we went down and then up. So this is called our minimum. Okay. And then F, same thing, we go up, but now we hit a vertical and then we go down. So which one do you think goes with F? What do you think?
22.
22? Okay, so let's look at 22. So here, 22, do you see how my slope is going down? And on F, my slope is going up.
Oh, I was looking at a different one. Oh. Sorry.
Were you looking at this one?
I was lost. I was just looking at the graphs. I was looking to the left.
Gotcha. Oh, okay, I gotcha. Yeah, so okay, so which one do you think it is? We're going up, we hit a vertical, and then we go down.
Is it 23?
Yeah, it'd be 23. So it's up, I hit a vertical, and then it goes down. Good. Okay, and then on the last two, we're doing everything negative. So it goes down and then down. Okay, So it's got to be 24, right? Because it's going down and then down, and it's ND. So I'm hitting that vertical right here at that critical point. So this has got to be 24. And then H is down. We hit a horizontal and then down. And so that's got to be your 22. And there's your horizontal and then down again. So this has to be 22. Okay. So you can see there's lots of different scenarios. What we're going to focus on though is our minimum when your slope goes down and then up, and then our maximum when your slope goes up and then down. If it's continuously up or continuously down, there is no change, right? There's no max and there's no min. So that's not going to help us at all. Okay. All right. So any questions on this? Because on the test, what I'm going to do is I'm going to have 2 or 3 graphs, 2 or 3 test charts, and you have to match them. So this will be one of the questions that we'll have on your test. Okay. All right. So now what we're going to do is now we're going to create those test charts and then create the graph based on our critical points. All right. So the one thing that I want to encourage you on this is for this test, you're going to get to, have your page of notes, but you're going to only do the steps. But what I want you to do is, because what happens is when I give steps, it's helpful, especially when you're first learning it, but sometimes one of the steps isn't needed. And so that just throws students. They're like, oh, I don't know what to do. So I want you to not focus so much on the steps, but focus on why are you doing what you're doing, right? Because I want the steps, right? Think of a stair step. I want the steps to suddenly become smooth and continuous. So you're just going to be able to smoothly walk through this whole process, because it is a process. And that's what you're learning in this class, is how to walk through a process. It's not necessarily just get the right answer, right? Plug the value in the calculator and get the right answer. It's you're walking through a process. So here's the process. The first one is you're always going to pay attention to the domain. So in these first few problems, this section and next section, the domain is always going to be the same. Where the domain changes is when we start to get into our word problems, our optimization problems. Now the domain is going to really come into play. So the domain is all of your X values. Okay, so that's what your domain represents. So everything that you can use as the X value, all right? So with a polynomial, in these, your domain is always going to be negative to positive infinity, all right? Because I can use positives, I can use negatives, I can use fractions, I can use decimals, doesn't matter. Right? I can use mixed numbers. I can use all of those different values for X. So there really is no restriction on the polynomial. Then what you're going to do is you're going to find your derivative. And the key and reason for finding the derivative is we want to find our critical points. Okay? Our critical points are where the maximum or where the minimum happens. So what's nice about this is, yes, there are an infinite number of values, but all I have to do is focus on the critical points, because the critical values or the critical numbers, those are the important ones. That's where your maximum happens. That's where your minimum happens. And that's the only place, at this point, that's the only place that your max and minimum can happen. So it takes an infinite number of values and it makes us focus on the critical values. All right. How do we find the critical values? We find our derivative, and then we set the derivative to 0 and you solve for X. All right. So let's just walk this through step by step. Oops. So our first thing, and I'm going to constantly bring you back to the domain. And this is only because I don't want you to forget about it when we're getting into the word problems. So our domain is negative infinity to positive infinity because we're dealing with polynomials, all right? Then we're going to find the derivative, right? And this is the easy part. We just find the derivative. So derivative of x cubed is 3x squared. The derivative of 3x squared is 6x. The derivative of negative 9x is negative 9, and the derivative of negative 11 is just 0, okay? So we found the derivative, we're good. The purpose in finding the derivative is so that we can find our critical values. We do that by setting our derivative to 0, all right? The minute you set it to equal 0, now you have to find what x is, all right? So, 2 ways to do it. 2 ways to find x. You are going to use the quadratic formula. That's one way. Or you can factor. Okay? With this one, I'm going to factor. How do I know? Because I've done it before. No, I can see I have a 3 in common. So when I divide 3 out, I get x squared minus 2x minus 3 equals 0. Now I can factor. What do I multiply to get negative 3 and add to get negative 2? So my factors of negative 3 are 3. Oops, this should be a plus, sorry. Positive 2. 3 and negative 1, or negative 3 positive 1. Since this 2 is a positive, I'm going to use this set of factors because my positive 3 plus a negative 1 is a positive 2. So when I factor this, I get x plus 3, x minus 1 equals 0. Okay. And then now I can solve because this times this times this has to equal 0. One of these or both of these have to equal 0. So I can say x plus 3 equals 0 or x minus 1 equals 0. So I get x equals negative 3 or x equals positive 1. Okay. So what I just found are my critical points. And that's the whole goal of finding the derivative and setting it to 0 and then solving. So find the derivative, set it to 0, and then factor or use the quadratic formula. Okay, so now I have my critical points. So now what I'm going to do, so let me come over here. So I'm going to write, so I have it, my critical points are at negative 3 and 1. Okay, so my third step is now I'm going to find the sign diagram or the test chart. I use both those terms. Okay, draw a sign diagram or a test chart for the derivative. All right, so now we're back to those test charts. So I have a test chart and I'm going to identify this as my derivative, just like the test chart had. Make sure you put your values on your test chart in order. Okay, don't mix them up. It's negative 3 and positive 1. All right, now this is the hardest part to grasp. But once you see it, it's going to make your life so much easier. So remember when we factored, okay, when we factored, I'll write it right above it, we got x plus 3 or 3 times x plus 3, x minus 1 equals 0. That's how we got our negative 3 and positive 1. All right. If you remember our test chart, all I care about is positive or negative. I don't care about values. All I care about is what is going on right in this interval from negative 3 down. And then I want to find out what's going on between negative 3 and 1. And then I want to find out what's going on from 1 and bigger. Whatever value I pick is going to tell me what's going on in that whole interval interval. So it doesn't matter what value I pick, just as long as it's in this interval. All right, so watch how I do this. So I'm going to find the derivative. Okay, notice this is the derivative chart. And I'm going to pick a value. So let's say I pick -5. I could pick -100, -10, -1,000,000. It does not matter, because in this whole interval, my slope is going to be either increasing or decreasing. Okay, so watch how I do this. My 3 is a positive, right? It's a positive. It's a whole number. 3 is positive. When I plug -5 into here, I get -5 plus 3, which is a -2. All right, so let me say that again. When I plug -5 right into here, I get -5 plus 3. That makes it a -2, so that means that term is negative. And then when I plug -5 in here, I get -5 minus 1, which is a -6. Notice I don't care the value. All I care about is positive or negative. So this is all multiplication. 3 times x plus 3 times x minus 1. So I look at what I have. I have a positive times a negative times a negative. Well, I have an even number of negatives. That makes the whole thing positive. So on that part, I have an increasing slope. Okay, just remember these right here. Oops, let me change my colors here. These are my critical points. So I really want to know what's going on either side of those. Is it going up, up, or is it going to go up, down? Is it going to go down, up, or down, down? We don't know. That's what we're testing. Okay. Now, the beauty of this is all I have to worry about is each term positive or negative. And then I multiply to see what the whole interval is doing. Okay. All right. So now somebody pick a number between -3 and 1. And let's test it. Give me a number between -3 and 1. -2? Okay. All right. So plug it in. So my 3 is positive. -2 plus 3 would give me a positive 1. -2 minus 1 gives me a -3. So that whole interval is going to be negative because I have an odd number of negatives. So that means this interval is going to go down. So what that tells me is I have a maximum right here. So my max is going to be at -3 something because it went up and then it went down. All right, now let's try the last interval. Someone give me a value greater than 1.
5.
Okay. And it really doesn't matter. I could have used 2, I could have used 200, doesn't matter. That whole interval, it's going to do the same thing. So again, my 3 is positive. 5 plus 3 is positive. And 5 minus 1 is also positive. So that makes this one positive. So this is going to go up, which means I have a minimum here. So I have a maximum and a minimum. Now, this test chart, if you use the arrows, is going to give you a shape. Let your eye see this and fill in those gaps. So it's literally going to look like this. It's going to go up, down, and up. Do you see it? Up, down, and up. So this is our sign chart or test chart. And again, all I care about is it positive or negative? Okay. All right, and again, that's why I'm saying this is all a process. The more we do it though, the process gets smoother and smoother and smoother. Okay, all right, so the next step is we have to evaluate. So we have our domain, we have our derivative, we have our test chart, and now we're going to evaluate. Right? Because we know we have a max and a min. We just don't know where it is on the graph, right? So far we know we have a max at -3 something, and we have a minimum at 1 something. We got to find out where it is exactly on the graph. So when you evaluate, you're going to plug the critical values into the original function. Original function, okay? Because we use the derivative on the test chart. When we evaluate, we go back to the original function, okay? So we just plug them in. So the original function was x cubed. So I have -3 cubed plus 3 times -3 squared minus 9 times -3 minus 11. Now, if you do this on your calculator, make sure you use those parentheses, because your calculator, if you plug in, remember that it's a really easy mistake. If you plug this into your calculator, it's going to give you -9. If you plug this into your calculator, it's going to give you a +9. So this is the correct way to put it into your calculator. All right. All right. So here we go. -3 cubed is -27. -3 squared is 9 times 3 is +27. -9 minus 3 is a +27 minus 11. So I can eliminate one set. 27 minus 11 is 16. So my maximum is at -316. Okay, so I'm going to come over here and graph it. And this is a sketch, right? It's just a sketch. You don't have to be accurate. I can come over here and go -3 and 16. There's my max. All right, now let's find out what our minimum is, where our minimum is. So we have f of, 1. Okay, so it's 1 cubed plus 3 times 1 squared minus 9 times 1 minus 11. So we have 1 plus 3 minus 9 minus 11. So we have 4 minus 9 is -5, minus 11 is -16. So your minimum is at +1, -16, right here. There's our minimum. All right, now the beauty about the max and the min is it can't go any higher than that and it can't go any lower than that. And you have the basic shape. That test chart gives you that basic shape. So all of the values that are less than -3, your slope is going to be increasing. It hits the max, it comes back through, hits the minimum, oh, that should be smooth, and then goes back up. It's just a sketch. All you need to worry about is where that maximum and minimum is. Now, you could make it even more accurate. This -11 is your y-intercept. Remember, y-intercept is when x is 0. So it's 0, 0, 0, -11 is the only thing that's left. So it crosses my y at -11. So you can make it a little bit more accurate. Where it crosses the y-axis is super easy. It's always this constant. So it's always the constant is your y-intercept. Okay, so that is the process. You find the domain, you find the derivative, you set it to 0 because you are looking for critical points. That's the whole point. You're looking for critical points. Then you're going to set up your test chart, figure out what your slope is doing, increase or decrease, find your max or min, and then evaluate to see where that max or min sits. Questions? Is there any spot in this that you're like, not sure where I got that? All right, here we go. Okay, so here is your chance now. So I can tell you that the characteristics of any function, so that you have an idea of what it looks like, the characteristics of, let me type this because it'll look better. So if I have characteristics of any polynomial, if I have x squared, it's going to be a parabola. You guys know that, right? You know what it looks like. It's going to be either like this or like this. Okay. If you have x cubed, it's going to have the shape of an S, if you will. It's going to be either something like this or something like this. You can see this is down and then up, and this is up and then down. That's what's called in behavior. Okay, but at least you have an idea of what your shape is going to look like. If you have, if you have x to the 4th power, that is going to look like, do it in a different color. It's going to look like this or like that. There's just some shapes to it. And then anything other than these three, it's going to be what's the term I'm looking for? It's going to be like these, but so for instance, if I have x to the 6th power, this is an even exponent. So it's going to have where the in behavior goes up, but I'm going to have more curves to it. These are called turning points. So I could have up to 5 turning points. So these are all your basic shapes. And then the exponent determines how many turning points I have. So this is an odd exponent. So odd exponent is going to look like your x to the 3rd, but there's just going to be more curves to it. And that's really the basics of all the shapes. And it's just nice to know so that when you're doing these, you have the basic shape. You know basically what it's supposed to look like. Okay? All right, so here we go. Step 1. Find the domain. With these, domain is always negative to positive infinity. I will tell you when that changes, right? When we get into word problems, you'll see, oh, there's a set restriction of the values that we can look at. Okay, step 2, you're going to find the derivative. Okay, then the whole purpose, why am I finding the derivative? Because I am looking for where is the derivative 0, right? Where does that derivative change? That's what I'm looking for. Where does it become? Where does the slope become 0? That's why you set it to 0, because that's where your maximum and your minimum is going to happen. And then you're going to solve. So this one I could do 2 different ways. I can factor out the x or the 3. Now I have difference of 2 squares. Okay. So again, this is another one of those instances where factoring comes back in. So it comes in and out of this class all the time. And then I'm going to solve for x. So x plus 2 equals 0, x minus 2 equals 0. So x equals -2 or +2. So this is one way to do it. The other, oh yeah, go ahead, Javier.
Oh yeah, where do you get the x squared minus 4 from?
Because I divided out 3. So I divided 3 off. I factored the 3 out.
And the
So-
4? What do you
And
Oh,
12
okay, I
divided
got
by
it.
3.
Okay, I got it. Thank you, ma'am.
Good question. Good question. Okay, so I prefer the factoring, and here's why. If you do it this way, and this is not incorrect, right? I'm going to add 12 to both sides. So I get 3x squared equals 12, and then I divide both sides by 3. So I get x squared equals 4, and then I square root, and I get x equals 2, because the square root of 4 is 2. This is where people make their mistake. When you square root, there will always be 2 answers. You have a +2, but you also have a -2. When you factor, you actually get the positive and -2. If you do it this way, then you have to remember, oh, when I square root, I get a positive and a negative. Okay, it's not incorrect. It's just one thing that you have to remember to do. Okay, so what did I just find? What does this x -2 and +2 mean? What are these?
The x-intercepts?
No, not the x-intercepts.
Critical points.
There we go. These are our critical points. Okay, so the x-intercepts would be where your parabola, like if you had a parabola like this, where it crosses the x-axis. That's the x-intercepts. What these are what's called critical points. So what we're doing is we're looking, where does our derivative, where does our slope go to 0? That's what we're looking for. Okay. All right, so the next step is we're going to use our test chart. And again, I label it because when I get to the next section, we're going to do second derivative and their graphs. And so it's the same process, but we have to know which one's the derivative and which one's second derivative. Okay. So I'm going to use my factored form. Okay, use my factored form. And to do my test, right? So I'm looking for this interval, the interval in between, and this interval. So I'll pick -5 again, just randomly. So my 3 is positive. -5 plus 2 is negative. -5 minus 2 is also negative. So positive times negative means the whole thing is positive. So that means in this interval, my slope is going up. I have an increasing slope. Okay, now I'm going to pick in between. Now, the easiest one, on the last one, you picked -2, right? But if I wanted to find out a value that's the easiest one to use between a -2 and a +2, I'd use 0. Anytime you're going from a negative to a positive, you have to cross 0. So I use 0. 0 makes it real nice. So my 3 is positive. 0 plus 2 is positive. 0 minus 2 is negative. So the whole thing is negative. So it's decreasing in that interval. And then the last interval, I'll just use 5 again. 3 is positive. 5 plus 2 is positive. 5 minus 2 is positive, so the whole thing is positive. Okay, so there is your maximum. Here's my maximum. And here's my minimum. Okay, maximum, minimum. All right, so I'm going to stop right there. On this test chart, is there any question on this part right here? Does everyone feel pretty good about that?
I have a question.
Go ahead.
The -5, 0, and 5, are those always just at random, or
Yeah, so you're going to pick random values within your interval. So this interval right here, I'm looking for any value less than 2, but less than -2, excuse me.
okay.
So I could have picked -100. I could have picked, you know, -3. It doesn't matter as long as it's in this interval, somewhere along -2 or less. And then same thing here. Between -2 and 2, I could have picked -1, 0, +1. Doesn't
I
matter.
got you.
I just picked the easiest one. Okay?
Yes, ma'am.
Okay. All right. So now last step is we need to evaluate, find out where exactly on our graph is our maximum and our minimum. So we go back to our original function and we plug our values in. So -2 cubed minus 12 times -2 plus 2. So -2 cubed is -8. -12 times -2 is 24 plus 2. So 26 minus 8 is 18. Yeah, 18. Okay, and then I graph it. Here's my -2. And again, this is just a sketch. It's just a very quick sketch of what this is going to look like. But I have to show my maximum and my minimum. Okay, and then I'm going to find out where the minimum is. So 2 cubed minus 12 times 2 plus 2. So 2 cubed is 8. Minus 24 plus 2. So 10 minus 24 is a -14. So I come over here to -14, and there's my minimum. Okay, now your test chart gives you the shape, right? You know it's x cubed, so you know it's going to be a serpentine, if you will, or like a S. Okay, it's a sideways S. So it goes up, hits that max, comes down, hits the minimum, and goes back up again. So I go up, hit my max, come down, hit my minimum, and then go up again. It's odd. I know it's got that S shape to it. Okay, any questions so far? And you can see this one went a little bit faster, right? We're starting to smooth out the process, right? At first, it's always going to be chunky and you're going to have to keep, checking, all right, what's the next step? Oh, that's right. I got to set it to 0, set the derivative to 0. What? But always ask yourself, why do I do this? I am finding the critical points. Okay. All right, here we go. Let me get this one separated here. All right, here we go. First step, domain. Okay, and you can see we don't really talk a lot about domain in this one, just because it's always the same, right? I can use any values I want for X. Where it comes into play is when we get into our word problems and we have restrictions. We have things that are going to hold us back. Okay, second step, find your domain. Why are you doing this? So that you can find the critical point. Okay, there's the domain. Again, just using your power rule, drop the 4 to the front, subtract 1, drop the 2 to the front, subtract 1. Now we're going to set this to 0. Okay. And now I'm going to factor. What do they both have in common? What value do they both have in common?
4
And what else?
and X.
And an
X.
X, yeah, good. See how they both have X's. So I am going to factor out a negative 4X, just because I don't want a negative on that front term. So when I factor out or divide out, same thing, that negative 4X from negative 4X cubed, I end up with X squared. When I divide out or factor out negative 4X from 100X, I end up with a negative 25. Now I have difference of 2 squares. Now, just in case, because this may come into play, what if you only factored out an X squared? Oops, it would be plus 100, not, or plus 25. You really do still have the difference of 2 squares. It's just not the way you're used to seeing it, right? So you can do it the same way, and you'll end up with the exact same answer. It's just now, if you rearrange this, now you'd have 5 minus X and 5 plus X. Well, over here, that negative 4X is part of it. I have X plus 5 and X minus 5. You'd end up with the exact same answer. I just don't want to deal with the negative in the front. So that's why I factor out the negative first. Okay, so this is the first time, if you notice, now we have 3 X's. Okay, in our other two, when we factored, we had 2 X's. 2 X's gave me 2 critical points. 3 X's means I'm going to have 3 critical points. So the number of X's makes a big difference. So I'm going to set every single one of these to 0. So I have negative 4X equals 0. So X has to be 0 because negative 4 times 0 has to be 0. I'm going to have X plus 5 equals 0. So X has to be negative 5. And I have X minus 5 equals 0. So X has to be positive 5. Now I have 3 critical points. And all that means is now I have more to work with, more intervals to work with on my test chart. So my test chart is going to look like this. I have, and again, make sure you put it in order. That makes a big difference. Okay, so because I have 3 critical points, now I have 4 intervals that I have to test. Everything below negative 5 going this way, everything between negative 5 and 0, everything between 0 and 5, and everything above 5. Okay, so the number of critical points can change. And then all that means is now I just have 4 areas I have to test. Okay, so here we go. And this is our derivative. We're looking for what is our derivative doing. So if I want a value less than negative 5, I can go negative 10. Doesn't matter. I can pick whatever I want as long as it's in that interval. So here we go. I have to place that in 3 different places, right? So remember, I'm placing it there, there, and there. Okay, so negative 4 times negative 10 is positive. Negative 10 plus 5 is negative. And negative 10 minus 5 is also negative. So that whole interval is positive. So it's going to go up. All right, so this is new. We have an X, a third X that we have to test. Okay, now I'm going to test between negative 5 and 0. I'll go negative 1, Just again, randomly, I could have done -4, -1, -3, doesn't matter. Okay, so -4 times -1 is positive. -1 plus 5 is positive. -1 minus 5 is negative. So that makes that whole thing negative. And then I'm going to test between 0 and 5. So I can plug in 1. -4 times 1 is negative. 1 plus 5 is positive. 1 minus 5 is negative, so it makes the whole thing positive. And then the last interval, I'll do +10. I could have picked 6. I could have picked 100, doesn't matter, any value in that interval. So -4 times 10 is a negative. 10 plus 5 is a positive. 10 minus 5 is positive, so it makes that whole thing negative. So now we have a little bit different scenario. We have it go up and then down, which that is a maximum. It went down and then up, so this is a minimum. And then it went up and then down again, so this is also a maximum. So you can have more than one max, you can have more than one min. So remember, we're dealing with all the x values, an infinite number of x values. Okay, so we can have that. So if you remember, our x to the 4th graph goes up, and down. So it's going to look something like this. Okay. And so your brain should be able to see that. It should be able to fill in the gaps, you know, right here, and right here. So it gives you a shape of what you're looking at. Okay. And then the last step, we have to evaluate. So now we have 3 places to evaluate. The good news is the 0 all goes to 0. So remember, our original function is -4x to the 4th plus 50x squared, just because we can't see it. Okay, so here we go. When I plug in -5, there's a lot of negatives in this one. Okay, so is that right? Did I write that right? Oh, it's x to the 4th. Okay. Thought that was too much information. It's negative x to the 4th. All right, so -5 to the 4th power is 625, but this negative makes it a -625. 50 times 25 is 1250. So 1250 minus 625 is 625. I'm pushing this ahead because I know we're running out of time. Okay, so one of our maximums is at -5 and 625. And then if I do the other maximum, you can see it's going to be the exact same thing. So that's also going to be 625, which makes sense, right? If I have 2 maximums, they better be the same. Otherwise, I have one that's more maximum than the other. So these have to be the same. And then when I have x is 0, obviously that all goes to 0. So I have a minimum at 0, 0. Okay, so sketch. I have 2 maximums and I have a minimum. So my graph looks something. So it goes up, hits the max, comes down, hits the min, goes up, hits the max, and then goes down again. Okay, so my graph should look very much like my test chart. Any questions? All right, real quick, this last one is a little bit different and I want to show it to you just because you may come across it. And again, you have to, excuse me, you have to trust the process. So if we walk through the process, right, we have negative infinity to positive infinity, that's our domain. We're going to set our derivative to 0. Then we're going to solve. Well, I can't factor anything out. There's nothing in common, but I can move my 4 over. I can divide by -3, but now I have x squared equals a -4/3. When I try to get x by itself, I'm going to square root. Well, now is the problem, right? I can't have the square root of a negative value. This is an undefined value. There's no such thing as a square root of a negative. So this is undefined. What this means is there are no critical points. Okay, so anytime you come across something like this where the answer doesn't make sense, that just means there's no critical points, which means there's no maximum and no minimum. Okay, now we're back to either it's all going to go up or the slope is all going to go down. So what you'll do is you'll go ahead and you'll do your test chart, but you only have to see, well, what's going on? Is it all positive or is it all negative? So you just put 0 in, you do all the negative numbers and you look at the positive number. You pick a negative and you pick a positive. So if I picked a negative and I'm looking again at my derivative, say -1, I'm going to plug it into here, right? It's my derivative. I don't have any positive or negative or no factored format of it. So I have to actually plug it in and see what my value is. So -3 times -1 squared minus 4. This gives me -3 times 1. So -3 minus 4 is a -7. So this interval is going to go down. Then I'll pick the other interval on the positive side. I can just do +1. And I'm going to get -7 again. So all this means is even though we know that the slope is going down, we have no critical points. So there's no max or min. But to graph it, all we know, we can graph it based on this. All we know is it looks something. We know what an x cubed looks like. We know it looks something like this. Something like that. Okay, it might be stretched out more so that it doesn't even go to a 0, right? It could be stretched out even further. Like barely moves. Okay, so all you need to know is, okay, is it all negative? Is it a decreasing slope? Or is it an increasing slope? So you just pick 0 when there's no critical points, you just pick 0, and that identifies negative and positive values. You pick a negative or a positive, you test it, and you see what your slope is doing. Okay, so don't panic when you get no critical points. It just means that there's no max or min. Okay? And you know the basic shape of an x cubed. Okay, any questions? All right, the good news is on Thursday, we're going to do second derivatives in their graphs. It's the same exact process. So do the 11.1, get that done, get your practice in, and then when we come to 11.2, it's going to be a piece of cake for you because it's just the exact same thing. We're just looking for what's called curvature. We're looking for how things curve. So like on this one, it curves down and then it curves up again. So that's what we're going to be looking for with second derivative. Okay. All right, guys, welcome back. Good to see y'all. And I will see you on Thursday.
Can I see the test chart for the previous one?
Yes, right here. Oh,
no,
no, the-
the one that
this one.
was yeah, the
Yeah. The X to the fourth.
yeah.
Mm-hmm.
So it ended up going down. Wait, did I think I copied it the opposite way. Oh no, wait, I got it right. Okay,
Okay.
so it ends up going down
Yeah.
uh,
Yeah.
after that.
So,
you
so
guys,
one thing, Orla, one thing that you can notice is see how it's a negative X to the fourth, the original function. That indicates that the end behavior is going to go down on both sides. If it was a positive X to the fourth, then it would, do something like that. It would both be up.
so you gotta choose. So when you're plotting it out on the test chart, you gotta do a number that's less than whatever you get, right? And then uh, towards the other number, the higher number, right? The positive number, I guess. You
Yeah.
would do a number greater than that.
Yes,
And
exactly.
something in between those. And if you have more than one in between those.
Exactly. Yep.
Okay.
Yeah. So like this interval right here, you'll pick a number between 0 and -5. But don't include 0 or -5 because you got that because it equals 0. So
Mhm.
you don't want to use your critical points. You want to use the values in between the critical points.
Okay.
Okay. Because the critical points, if you look at the graph, the critical points, that's where your slope is 0, right? It's 0 there, there, and there.
So you wouldn't use -5 or 0 because you already have them. So
Correct.
you would want to check if they're correct. basically.
Exactly. Yeah. Because you just get 0 again because that's what you did. That's how you got the -5 and 5 is you set it to 0 and then solve. Okay. And remember the 0 means that's your slope, right? So you have a horizontal line there.
All right. Well, I think that was it. Have a good day.
Okay. Thank you, Orlin. Talk to you later. Gennaro, Adam, you guys good?